Hey everyone, Chang here and welcome to my channel. Now, for today's video, I want to focus a little bit more on math. As fun, as amazing as showing study strategies and all that stuff was, it's definitely entertaining for me. We definitely have to go back to our roots. Now, today I want to go over a concept that I feel like a lot of us intuitively grasp. When we're first introduced to it, it makes absolute sense. However, afterwards, we sort of brush it to the side, right? We sort of ignore it. We don't realize how powerful, how amazing this concept is. So I do want to put a little more heavy emphasis on this concept for today's video. So let's talk about it. Now, before that, I want to introduce you guys to a problem. A problem that I think actually probably 80 or 90% of you guys will get it wrong based on your gut reaction, your gut instinct. So we're going to go over that, and then you guys can sort of guess what concept I am talking about. So let's just look at this really quickly. All right, first and foremost, this problem is fairly simple. Imagine you have a lake and you have a single bacteria on it. Okay, in that bacteria, the lovely thing about bacteria is the fact that in order to reproduce, it basically doubles itself. Let's just make it a fairly simple problem, and let's just say the bacteria doubles itself after every day. Okay, cool. So the other thing I'm going to add is that with that bacteria, after 30 days, right, the bacteria covers half the lake. So my question to you guys is, if after 30 days it covers half the lake, how many days will it take for the bacteria population to cover the entire lake? Ready? Go. All right, cool. So for a number of you guys, and probably very similar to me when I first saw this, our gut instinct, our gut reaction, bacteria population takes 30 days to cover half the lake. Boom, double it. So 60 days should cover the entire lake, right? That was my first gut reaction, and I'm sure a number of you guys as well. Now, here's the lovely thing about it though. That's not the case, right? Let's look at it in a different point of view, a different perspective. On the 30th day, the bacteria covers half the lake. Okay, we got that. The bacteria doubles after every day. So the next day, this entire bacteria population doubles. So if it's already half the lake, that means actually 31 days. That's all it takes for that bacteria to cover the entire lake. Now, when I first heard about this, I heard it was a problem to teach you guys the bad or the negative consequence of procrastination. And what better way to show you than instead of an extra 30 days that you have it, you actually only have one more day before you're kind of screwed. Now, here's the thing. You guys can guess. The concept is the idea of exponents. Now, a lot of times we might not hear the exponents out in the real world. We hear about compound effect, compound interest, compound whatever, which is actually another play on the concept of exponents. So if you hear that used interchangeably, yeah, they are slightly different concept, but they're so interrelated that some people use it that way. Now, the lovely thing about exponent is the fact that it starts off super slow. And there is this one period where all of a sudden it just becomes crazy, right? So for those guys who are comfortable, you guys seen it before. The graph of exponent is fairly simple. You start off and for some reason it's just drastically slow. Then all of a sudden it shoots up, right? Now it's always drawn in comparison to usually a linear graph, which usually is a steady state climb. However, no matter how steady it climbs, there is always going to be a point where exponential, compound, right, exceeds a linear growth. So why is that important? Because guess what? One of the most important thing in terms of, for example, finance is the idea of compound interest. When you put in something and it builds over an extended period of time, at first you never really see much of a change. All from here. And then all of a sudden, for some reason, after a while, it starts shooting up like a rocket. Okay? And so, when you are investing, I'm not an investment channel or finance channel or anything, but understand that compound interest actually plays wonderfully, better than linear. Right? It starts off small, but eventually, it reaches a critical mass, a certain point, and boom, it starts shooting up. So that's what we always want to play with. And this idea of exponents, this idea of compound plays in a lot of other places. Right? Bacteria is one of them. Algae growth, I think, is roughly the same thing. And then you have your finance, your compound interest, and a lot of other things, right? you have your, whole nuclear growth and decay and all that other stuff. So exponent plays a lot of critical role. Now, here's one thing that I thought was really cool. And it's not necessarily math related, but I love the fact that they use this concept of exponents, this concept of compound, right, to be a motivating factor. And actually, I think it plays really well. And it's the idea of the 1% rule. 1% rule. Okay, and I heard it introduced in a lot of, top motivation speakers like Tony Robbins and a lot of others. But the idea is that you want to improve every single day. And it's always something very small, right? Something that you can do gradually. And the lovely thing about it is that it does follow this sort of exponential or compound effect, right? The idea is that, let's just say 1. If we're talking about percentage, right? 1 is your 100%, where you are right now. So, if you do 1 times 1, you can get 1. Right? So that means if you don't change, you're just always going to be the same. All throughout. 1 times 1, a million times. A billion times is still going to be 1. However, just minute incremental change. What's this? 1.01. Basically, a 1% change. Now, it doesn't seem like a big deal, right? Because then when you multiply 1.01 times 1.01, you get about 1.02, right? And then you multiply again, is about 1.03. And it seems like that's absolutely nothing. However, guess what? After 30 days, it's about 1.34. 1.34 means that you've just increased. You've grown about 34%. That's a third plus, right? Which actually is drastically different, drastically amazing. You've grown a third more. Now, that's one thing that's not math related. Now, the other thing that I thought was really cool, that I think I might have mentioned before, but if not, is something that I dare you to play with your family, friends, teachers, whatsoever. Ask them for a single penny. All right? Double it every time. For a month. Right? So, every day they're going to double the amount. The first day they give you a penny. What the hell is a penny? Doesn't matter. Second day they give you 2 pennies. Okay, what the hell is 2 pennies? Doesn't matter. Third day they give you 4 pennies. Okay, 4 pennies. And then 8 pennies. Then 16 pennies. 32, 64. And then tell me what happens after 30 days, right? What is the dollar amount that you would actually have? It's actually pretty cool if you really think about it. Anyways, hopefully these several examples will show you some of the really cool stuff about compound, about exponents, because I really want to emphasize the fact that there's going to be a lot of examples. I'm going to go into some of the other videos where you can actually use exponents, you can use compound to explain certain situations in the world that maybe at first glance doesn't make quite much sense, but when you use the idea of exponential, of compound, right, then you start to see how certain concepts, certain situation doesn't play out as well as you hope. And here's a little teaser for you guys. It's probably not the complete explanation, but guess what? The idea of a pyramid scheme does play with this concept of exponents. Anyways, that's a teaser for you. I will make that in another video. Thank you for watching. If you haven't already, please like, comment, and subscribe. I will see you in the next video.